Welcome to this session on how to identify barriers for non-market goods. This is a continuation of the previous session, which focused on the process, the general process of market analysis, which focused on how to identify barriers through brainstorming in a stakeholder group, and which focused on how to prioritize barriers, how to screen barriers, and how to decompose barriers into its specific components to be more detailed. This component, on the other hand, will focus specifically on barriers for market goods. And what are market goods? Market goods are consisting of two categories, consumer goods and capital goods, which are illustrated here on the left part of the screen. Consumer goods are characterized by being diffused on a mass market, and technologies within this category could be solar home systems, drip irrigation tubes, or it could be mosquito nets and other technologies which are diffused on a mass market. The capital goods, on the other hand, is sold on a more restricted markets. It's often bigger types of technologies, and examples could be cement factories or power plants. What is characteristic for the market goods is that government, if they want to stimulate diffusion of these technologies, can only do so by changing the market conditions, what we normally call the enabling framework. The content in this component is twofold. First, an economic assessment, and secondly, a description of the market mapping approach to barrier analysis. The economic assessment is basically assessing to which extent the given new technology is competitive with existing technologies which are already in use out there. I will illustrate that with this well-known figure showing the decreasing cost of a technology when it moves in stages from demonstration through diffusion to being commercially competitive. The cost of the competitive technology is the baseline here. The cost of the new technology is in general higher than the baseline. And this is because in this TNA project we focus on technologies which are often more expensive than the baseline and therefore need some support from government or from others. And when we are interested in these new technologies, even though they are more expensive, it is because there are societal benefits related to these technologies, such as, for example, CO2 emission reduction or reduction of vulnerability for rural poor. The size of the economic barrier is best illustrated by the cost of the difference between the cost of the new technology and the cost of the baseline technology. It is therefore also evident that it's most important to select the right baseline. And the baseline is technologies which are already in use in the given context. So for solar home systems for individual consumers in rural setting, it would be a small generator set which would be the most likely alternative to provide the same type of service. For large-scale grid-connected solar power, it would be a diesel generator also connected to the net, which would be the most reasonable comparison. If we look at drip irrigation, sprinkler irrigation would be what is existing in some cases, and in other cases, no irrigation would be the most reasonable baseline. And for improved seeds, the baseline is naturally traditional seeds. So how do we actually conduct such feasibility analysis or simple cost-benefit analysis? To illustrate that, I will use the case of drip irrigation. When doing economic assessments, we start out with the cost elements. We calculate the annual cost, which consists of one part, the capital cost for the whole system. So this is the capital cost for, in this case, the pipes, the pump, and maybe even the well. So this is the investment part. There are two other elements, the interest rate and the lifetime of the investment, which is necessary for calculating the annual capital costs. Another cost component is the operation and maintenance cost. It consists of labor, spare parts, and other maintenance components. And on the revenue side, we will here compare to the situation of no irrigation. So we will look at the increased production, the increased yield in here based and find the price for sold at market value of this increased yield. We will then, based on the annual costs and the annual revenues over the lifetime of the investment, calculate the net present value, the internal rate of return, and the payback period. And if the net present value of this investment is positive, then drip irrigation is competitive with no irrigation. If the net present value, on the other hand, is negative, then drip irrigation is not competitive to no irrigation. And in this case, there will be a barrier, an economic barrier for drip irrigation. There would be other advantages, but there would be, for the investor, there would be an economic barrier. In some cases, as mentioned before, drip irrigation would best be compared to sprinkler irrigation. And in this case, we would again look at the annual costs consisting of capital costs and operation and maintenance costs, exactly as we did for drip irrigation. We will look at the annual revenues, and we will compare that also to the baseline of no irrigation, and we will calculate the net present value and the internal rate of return and the simple payback period, and we will now compare the two technologies, the cost of the two technologies. And the parameters for comparison would be the net present value and the technology which has the highest net present value, which will be the most feasible technology. Another comparison would be the internal rate of the return, and the technology with the highest internal rate of return will be the most feasible. Similar for the technology with the lowest payback time will be the most competitive. Most consultants would have in their toolbox a small spreadsheet model which will be able to do this type of simple comparison of costs and benefits for a technology. If not, there are a number of other available computer models on the web. One of them is the FICAM model, which is available on the TNA product websites. Another example is the RedScreen model, which is used for comparison of renewable energy technologies. Besides the economic assessments, we will look at two other tools, the problem tree and the market mapping, which will be better suited for identifying and analyzing other types of market barriers. The problem tree is used to identify a root cause through, you could say, logical deduction of the problems into more details. This tool is well known from the logical framework analysis, which I think most consultants will be familiar with, and therefore we will not in this component spend time on this. We will, on the other hand, focus on the market mapping approach. And the market mapping approach has its main focus on the market chain, the actors in the market chain and the connections, the relations between the actors. So it is about how this market chain will function, where are the barriers for proper functioning, and where are the bottlenecks. Such a market chain will be serviced by a number of service providers such as banks, infrastructure services, insurance companies, and others. And it will be regulated by what we call the enabling environment. It consists of broad things such as norms and values in society, and more specific things such as regulations, policies, laws, and acts. The benefit of using the market mapping approach is that it shows all the elements which are necessary for a market or a value chain to function, and it will open the eyes for the group sitting doing this exercise that barriers and bottlenecks can be found at many different places in this system. The market mapping approach is drawing its inspiration from technology innovation system approach and the value chain approach, which is well known from the research community. And we can say here that the problem tree is illustrating a form of linear thinking, while the market mapping approach is illustrating a system thinking. To exemplify how the market mapping can be useful for a group of stakeholders for identifying barriers, I will take you through this example, which is a simple example of a market mapping for the PV industry. First, we will focus on the market actors, the consumers, here on the left side. On the right side, we have the importers of wafers, panels, and batteries. In the middle, we have the local production. And here, also in the middle between the production and the consumers, we have the retailers and the battery wholesalers, which are very important to make this system function. Demand from the consumers is met by the PV system retailers. Again, they get their products from the assembly factory or from importers of PV panels. The assembly factory gets its wafers from external resources through an importer. And similar, we have a chain on the battery side from the PV system retailer to the importers and the producers of batteries. Also, the consumers need maintenance of their systems, so they have a relation to the maintenance providers. So this is a very simple description of the market actors and the linkages between them. So what are the barriers for this system to function properly? We will start here on top, looking at the enabling framework. We have, or the group which are in the room, have identified 4 general barriers: corruption, unclear finance policy, poor trade standard, and low contract enforcement. But going into details, they also point at high cost of imported products, which are linked to these actors. Some point at poor conditions for the local industry. Other points at high interest rates for the consumers. Others point at low awareness for the consumers of which products are available on the market. And many points at high cost of finance as a problem, maybe for all actors in the market chain, but in this case specifically for the consumers, for the retailer, and for the factory which is assembling panels. Others claim that sales are not coordinated between the different actors in this part of the chain. Again, others find that components produced by the 2 local producers are not really matching each other. They do not fit well into a proper system. And finally, a number points at low quality of products which are imported, but also low quality of products produced by the local assembly factory. In general, they point at low research capacity, they point at low technological skills, and they point at a poor market information. So, evidently, it has now become very blurred and complicated, but it serves as a good tool for providing an image of all the elements of the systems and also which actors and which chains in the system that the barriers are related to. On the other hand, one might also lose some of the details, and because of that, I'll try to recapture what we found in the analysis. We found a number of general barriers. The first one was unclear finance policy. We found poor trade standards. We found low contract enforcement. We found corruption. But we also found some general barriers such as low research capacity, low technical skills, and poor market information. These barriers are so general that they're not very much linked to the PV industry as such. They will probably also be valid for a number of other technologies. So they are important and they should be dealt with, but for this example, we will return into the specific barriers for this technology. And first of all, we have the economic barriers, which consist of three elements: the high cost of products, the high interest rate, and the high cost of finance. We also found low awareness of PV products, poor conditions for local industry, and that sales were not coordinated. And finally, that components didn't match to fit into a system. So what we see here is that we have now a number of headlines, but it's very important not to stop at this level, because to make sense for the next exercise on how to find measures to overcome these barriers, we need to know much more detail about the barriers. So for each of these headlines, the group need to go into discussion and details of how the barriers are perceived by different members in the group, and this will best be done through a narrative at the end, which can be put on paper. So we are basically returning to what was in the previous session, that we need to prioritize, and not least we need to decompose these barriers into a number of elements. So to sum up this component, firstly, we introduced economic analysis to assess economic barriers. We touched upon the problem tree to identify root cause of barriers, and we finally went much more into detail with the market mapping to assess barriers from an innovation system perspective. And not least, we emphasized that all barriers need to be prioritized and to be analyzed in details. If you need more information on barrier analysis for market goods, you can consult Chapter 4 in the second edition of the guidebook here, which is available at our project website.